Okay, so everyone, let's write the dates. Today is July 5th. So this is lesson homework class 1. Okay, I'll write next time. So yeah, let's just pick up this one first. So everyone can flip the book to that page. I also have to flip it to that page. One sec. 1.6. 1.66a. Okay. So evaluate each with our calculator. Okay, so the question is evaluate. Do we write notes for the homework lesson? What do you mean? I don't understand what you mean, Alan. Okay, so we want to evaluate. If you recall, means we want to calculate until the end. But here, without the calculator, maybe once when you see it, you already see that without the calculator, then we don't really want to do it just directly multiply, right? Now, but you should recognize here, this is the power of 2, this is the power of 5, here you have a power of 2, here is just the power of 5 and 2 also. So yeah, everything is 5 and 2s, 5s and 2s. So let's write everything in 5s and 2s. That maybe is can be easier. So recognize the powers of 2 again. So even if you didn't memorize, I hope you somehow right here, 1.6.68. Do you see it? Okay, so I hope you recognize the powers of 2. So this is 2 to the 5, 5, 2, oops, and then 5 square. And then 2 to the -2. And here, of course, I want to break this up to powers of 5 and powers of 2 because I want to collect all the 5s and I want to collect all the 2s. Okay, Jeremy, what?
Where's the online version of the questions?
It was on the resource tab.
Because it's not there.
Yeah, now it is gone. I don't know why, but yesterday it was on the resource tab.
Can you like add it back in?
I don't have it. I would ask, or maybe you can ask the actually anyone here has the PDF file. You can send on chat. And anyone. So okay, so someone asked the whole question. I'll take up the whole thing. Yeah, again, anyone have it, then can you post it? Just post the file on chat. Yeah, so you all can see it. Okay, so yeah, continue. 5 to the -3 and then 2 to the -3. So as I mentioned before, collect all the 2's. We start with 2 to the 5. If we multiply, we add the exponent. So multiply here, add this -2. If it's divide, we minus the exponent. So dividing here is minus this exponent. Collect all the 5 is 5 square. Multiply, then we add this exponent. So here we have 2 to the 5 minus 2 plus 3, that is 2 to the 6, and then 5 to the -1. So that is you recognize the powers of 2's and powers of 5. So this is the top is 64. This is negative exponent is 1/, right? Is at the bottom. So that is just 5. Okay, up to here, make sense? Okay, let's do B also. So we want to do -2 4 times 3 cube, and then the whole thing cube, and then times 8 times 27 over 2 cube, 3 cube, the whole thing to the 4. Okay, so here same thing, we recognize everything's the powers of 2's and 3's. So let's write everything in terms of powers of 2 and 3's. So here negative. Now notice this thing here with or without the bracket is not the same thing. With the bracket, -2 to the 4 is a negative. You multiply negative 4 times is a positive 2 to the 4. But if you have negative 2 to the 4, that means it's a negative number. That is a negative, negative 16 in other words. Okay, maybe I'll write here, just the number is 16. So here without the bracket means this is a negative 1. Okay, so it's a negative number to the cube, or as you know, negative means negative 1. So negative cube is negative, right? So negative cube is negative. 2 to the 4 cube is 2 to the 12. 3 cube is 3, 9. And here 8, you recognize this is 2 to the 3. 27, you should recognize this 3 cube. Bottom here, 2 cube 4 is 2, 12. 3 cube 4, that is 3, 12. Okay, so here you can collect them, or maybe you just see that this top-bottom relationship is this top-bottom relationship is multiply, divide, so we can cancel it out. Otherwise, as I said, even if you don't do it, you can do that. Start with 2 to the 12. When you multiply, you add exponent. When you divide, you subtract exponent. Collecting the 3's is 3, 9, and then plus 3, you multiply, and then minus 12 when you divide. So one thing is you see here they cancel anyway, right? So that is just 2 negative is negative, and then 2 cube left. And here you can think of, as I mentioned before, if you picture this in your head, 3, 3, 3, you have 9 of them. And here 3, 3, 3, you have 3 of them. Bottom is you have 3, 3, 3, 3, 12 of them. Also, they just cancel all 12 of them. So here you can see that they cancel. One thing is you can see right here, you have 9 3's, and then 3 3's together is 12 3's on top. Bottom, you have 12 3's exactly. And so when you cross out all 12 of them, they are just all divided, it's just 1. So right here you can see it, or now here you can see that it's a 3 to the 0, which is exactly 1. Here, 3 to the 0, that's just 1 anyway. Yeah, so at the end, so you can cancel it, or you can just collect them. It happens, since they happen to just cancel. So at the end, it's just negative 8. Okay, up to here seems good. Quickly write those down. If you want, you can just take a screenshot also. Okay, anyone not done, type me a letter N, please. Again, I want to remind you, first you understand as I speak. You don't need to worry about copying. Yeah, N is fine, I can wait. 1 minute, not too long, but okay, you first understand. Okay, first understand, quickly copy, but if at the end you happen to be too slow, you just take a screenshot. Okay, so while you're writing, I'll write question C. Yeah, I'm going to write C now. So here we have 94 to 7. Okay, everyone please understand what I'm doing. I'm going to someone asked for 1.6.6a before, but later someone asked for 1.6.6. So I crossed out the A, means that I'm going to the whole question. So I did A and B, and I'm going to do the C. So please see that what I'm going to do. If you have questions not written here, then you ask on chat. Okay, but if something is already written up here, then you don't have to ask again. I'm going to take it up. Okay, so yeah, part C here is this over. Maybe someone not done here. Okay, 2 to the 30 times 25 to the 3. Okay, so 40 maybe doesn't look, maybe you didn't recognize it's a power of something, but 40, of course, I mean, the bottom gives you a hint. This is power of 2, this is power of 5. Probably you quickly think about 40. Is it a power of anything? Well, 40 is 4 times 10 or 5 times 8. 40 is 5 times 8. I mean, that is 5 times 2 cube. Yeah, so the 40 is also made up of 5 and 2. So the whole question is just made up of 5s and 2s. Okay, so let's write like that. This is a negative 40. 2 cube 5. This is negative 40. First, right here, negative 40. And then to the power of 7, 230, 25 cube. Now, next is, as I mentioned before, right here, negative without the bracket means this is a negative number. So you see again, negative to the power of whatever is, then you have negative times negative, negative. So negative to the power of cube, the power of 3 means you have a negative, negative, negative 3 times. So negative times negative times negative, the final answer is negative. Here, negative times itself to the 7 time. So at the end is a negative number. So this is a negative to the 7 is negative. 2 cubed to the 7 is 221. 5 to the 7 is just 5 to the 7. At the same time, of course, I write this in terms of, actually, I should have done it here. I recognize everything is in terms of powers of 2 and 5. So let me change this to 20 powers of 5 also. 25 itself is a 5 square. Like this is a 25 first, and then to the exponent 3. Okay. Anyone still not done the top? Type a letter N again, please. Okay, so I don't have to squeeze here. Okay, I'll go back to it later. So 5, 2 cubed is 5, 6. Okay, so now we see 5 negative, and here if we cancel 9 of them, there are 9 left at the bottom. And here cancel 6, then you have 1 left on top. Remember I said that you cross out the exponent to cross out exponent means you have just 1 5 left. And I cross out the exponent is not just 2 left, it's 2 to the 9, so I better keep it clear. So yeah, I do like just 2 to the something. I still have it here. Okay, so negative top is 5, bottom is 2 to the 9. And maybe you recognize 2 to the 9 is 5 on 2. Yeah, if you didn't, try to recognize them. And 5 and 2, it must be lowest term. Okay, that's it. Write down quickly. Let's see if we have question D here. No, okay. So before I continue, session 1.7, anything you want to ask? Okay, so finish writing here. If no one asks anything, I'll go to session 1.8. No one asks anything, I'll do from the bottom to the top. So I'll do all the 1.8 first, and if we have time, then I'll do 1.7. So if you have questions, you better come to class and ask, because you couldn't expect in one homework class, we take up all the questions. So if someone is thinking, okay, I didn't finish the whole thing and I'll just wait for the homework class, then it doesn't do. Okay, 1 point. Okay, yeah, please type it earlier. Okay, 1.7 now I went to 1.8 already. Now I'll go back to 1.7. So you all have questions prepared. You know, before the class, I already asked if you have questions, you type on chat. So next time, I hope you guys do that. Just right before the class, you have your questions ready. So when I ask, you type them out. 1.8.4, yeah, this one I wrote down already. Okay, 1.7.5D. Okay, so what do we want to do? Let's read the question first. Evaluate without calculator. Also, it is the same question. Okay, so this question now, just in case someone is not following. Okay, we want to, again, it's the same question as before, evaluate. But without calculators means we want to, of course, simplify it first. So 5 cubed, and then here 3 over 5 over 3 over 5. And then 5 to the negative 1 over 5. Okay, so yeah, same thing. Maybe, I hope, not maybe, I hope you recognize they are all powers of 2. Hold on, it was 1 over 5. Okay, so I hope you recognize they are all powers of 2s and 3s. So let's 2s and 5s. Let's write them in terms of 2s and 5s first. So this is a 2 cubed. This is the 8 first. 8 square. If you do it one step by one step, okay, just in case if you think, okay, sometimes I am, you know, you are careless, also you are not quite sure, then better do it carefully. This block is 8 first. This is 8 square, so I have an 8 and then square. All right, here 3 over 5, and here 5 negative 1 over 5. I want to collect all the 2s, but here looks like 2 to the 6, but that's not quite it yet. because I have 2 to this block here, still have to raise it to this exponent. So yeah, I will simplify one quickly. 2 to the 6, 5 cubed. Keep simplifying. 6, this is the ABN rule. This, whoops, ABN rule is that they are multiplying. So the A have to raise to this exponent, the B have to raise to this exponent also. When you raise to exponent, that's the AMN rule, that you multiply the exponent. So this is the 2 to the 6 times 3 over 5, which is 18 over 5. This is a 5, 3 times 3 over 5, which is 9 over 5. And then bottom here is 2 to the 3 over 5, 5 to the negative 1 over 5. Collect all the 2's and collect all the 5. Now again, you see, I told you, oh, I didn't maybe. Okay, but we know that the multiplying dividing relationship. Here, even if we think of it like this, fraction will be like top times top, bottom times bottom. So we can just do the 2's by 2's, 5 by 5's, as I mentioned. Number by number, x by x, y by y, number by number, radical by radical. Right, so here we collect all the 2's will be 2 to the 18 over 5 first, and then you are dividing, so you subtract exponent. Collect all the 5's will be, you start with 9 over 5, and now you divide, you subtract exponent. This exponent happen to be a negative number. It doesn't bother us. Just whatever m, you see if you have am over an, just whatever m minus the whatever n. So here you have this whatever number minus this whatever number, whether it's a positive or negative. So here I have just this number, and then minus this number. It happens to be negative, doesn't bother me, just minus it. Okay, so here that is a 15 over 5. And here, of course, it's a 10 over 5. Okay, woohoo, they work out to be nice integer. So that's a 2 cubed times the 5, 2. Now that's a 8 times 25. You can think of it like this, or also you know that 2 square combined with a 5 square make a 10 square. So that's a 100, that's a 2, or that's a 10 square. Maybe I'll write it this way. You all know 10 square is 100 anyway, right? So 100 times a 2, that's 200. Okay, any question from this 1.5.7, 1.7.5? Someone asked D only. So are any people want part C, part A, or? Okay, finish writing it down and tell me if you understand it. And I'm flipping to 1.8 now. Okay. Yeah, you don't have to tell me that. Well, thank you for telling me you understand, but actually in general, you don't have to type to me, because I'm just waiting for, you asked it, great, but I bet other people didn't, I bet there are some other people didn't do this question either. So I'm expecting some other people are writing this down. So I'm just waiting a little bit for everyone, not just for the person who asked this one, is for everyone. Okay, so anyone not done this one, type the letter N, please. Okay, next is 1.8.1. Let's see, someone asked for part D only, I think. Okay, then I'll do D first, see if we want any other parts after. Simplify each without calculator. Okay, so the question is simplify. Okay, this one is about that we understand what is a square number. So let me add some notes here. 6.76, that's the question. Okay, now side note, so let's write the note. What are square numbers? Because here we are taking square roots. When do we know something are perfect square, that we can take square roots, and when are not? So what are the perfect square? Write those down, notes here, right? What numbers are perfect square? Okay, so first of all, we know the square numbers. Now, I didn't write it down specifically because I assumed you guys know it already. But now, since we are in homework class, I have time to talk a bit more, more detail than I will talk about now. So first of all, the square numbers are 1, 4, 9, maybe, or you can tell this is a 1 square, 2 square, 3 square. Those are called square numbers. 16, 25, 36, and so on. You know those already. So those are called square numbers. Now, if they are integers, then they are very easy to recognize. What if they are not? So what meant to be perfect square? Let's look at the powers of 10. For positive powers of 10, let's understand the some pattern. So let's look at 2. We all know that 2 square is 4, right? No problem. Let's consider 20 square. If you have one more 0 here, what happened? Now please understand, okay, or maybe you see it already. 20 square exactly is the 2 times 10 and then square. Means like you have the 2 is squared and the 10 also squared. So you have this part is the 4 part, the 2 square will be the 4. The 10, the 0 square, the 0 means the 10. The 10 square, you will have 100. So of course, then you have just 400 here. This is 100, this is 4, okay? If we have one more 0 here, what will happen? Well, this is the 2 square, and then the 100 square. So you know 2 square is 4. 100 square is, you just have, 100 is 2 zeros. So when you square, you should have 4 zeros. Yeah, so this number has 4 at the front and then the 4 zeros, 4 trailing zeros. Okay, from this, I think we understand already that to be a power of, to be a perfect square is that you must have even number of zeros. Let me show you one more. So what if you have 2 digits? Let's consider 11 square. That's 212. If we add 1 0, what happened? This is 11 square and then a 10 square. 11 times 10. So this part is 1 to 1. This part is 100. So yeah, it is the same thing that you have the non-zero part is a square number. Then the 0 part, you will have 2 zeros. Okay, just do one more. What if we have 2 zeros instead? 1 square, 100 square. This is 11 times 100. So the 11 square and then the 100 square. That's 1 to 1 and then 4 zeros. Okay, again, from this we see it. To be a perfect square, the front number is a square number. And the trailing zeros must be even number of zeros. If you start with 1, you square, you will 0, 0. If you start with 2, you have 0, 0, 0, 0. So yeah, if you have 3 here, 3 zeros here, then you will have 1, 2, 3, 1, 2, 3. You have 6 zeros there, right? So we'll recognize this. Okay, so let's write down here. To be a perfect square, the rule is to be a perfect square. So of course, the non-zero part at the front is a square number. Okay, and then after that is that you have the number has to have even number of zeros. Okay, so for instance, 900 square root, yes, is a nice integer, but root 90 is irrational. Okay, maybe I'll write here instead. Rational included the integer already, right? Okay, maybe I'll write integer. Does it make sense? 2 0 is good, 1 0 is no good. Okay, now for the negative, here decimals are the negative powers of 10. So I will come back to this after. So I'll write down the negative powers of 10 first. for negative power. So I mean, for some people who are not done writing, okay, don't worry, I'll go back up. Negative powers of 10 means the decimals. So let's consider 2 and 2-digit 11 also. 2 square is 4 certainly. 0.2, what if you have one decimal to begin with? Now this is a 0.1 times 2 and then square. So that's a 0.1 square and then 2 square. This is the 4 part. Even if you think of it like this, don't have to copy this down. If you think of it like this, you can see, yeah, you always just get the 4. But we know the decimal multiplying rule is that one decimal place means at the end it should be 2 decimal place. Yeah, so at the end should be 2 decimal place. Otherwise, you know, 0.1 square means just 001 is 2 decimal place also. So either way you understand it, either way you recognize it, they are the same thing. So 0.01 and then times the 4, that gives us the 0.04. Okay, let's see one more. 0.02, let's have one more decimal place. So that is, you recognize it's a 0.01 square and then the 2 square. This part you have the 4. You see 2 decimal place times 2 decimal place square means the 2 decimal place times the 2 decimal place, then you should have 4 decimal place. We know the decimal multiplying rule, right? So this here is 4 decimal place. And so that's a 4 decimal place and then a 4. So we expect here should be just even number of decimal place, not even number of zeros anymore. Okay, here you have 3 zeros. Now, but this is 1 digit. What if we have 2 digits? Okay, so 2 digit is 1 to 1. If you have 1 decimal place only, now you see again here, even if you do write out 1.1 multiply, well, essentially you are just doing 11 times 11. But at the end, you count 1 decimal place together is 2 decimal place. So this is a 1, 2, 1, 2 decimal place. Same thing here, move 1 more decimal place, 0.11. Is essentially you are doing just 11 times 11. So that's 1 to 1. But 2 decimal place at the end should have 4 decimal place. So here, this number should be 1 to 1, but with 4 decimal place. That's 0.0121. That's 4 decimal place with the number being 1 to 1. Okay, so for the negative powers of 0, like negative powers of 10 means like the decimals. To be a perfect square, you need to have an even number of decimal place. Not number of zeros anymore. Okay, so you get whether it's a 1 digit or a 2 digit, it is about decimal places. Okay, so again, don't worry, I'll come back to it. Let me finish this one now. First, we recognize. So here again, without the calculator, can we do it? Is that first we recognize 6.76 is a square number. First recognize. I think you all know the square numbers quite well, right? I think 676 equals to 26 square. And next is, this is 2 decimal place. Next, 2 decimal place, even number of decimal place. Means the original is 1 decimal place. So you see again, 2 decimal place here means you are 1 decimal times 1 decimal. That's how you can get 2 decimal. Okay, so the 2 decimal place here means the original number, the base, when you have something like if you want this to be something square. Okay, so this number, the base is 1 decimal place. Okay, 2 decimal place means that the base or the original number, okay, is 1 decimal. Okay, so yeah, this is a 26 when you square root, but 26 with 1 decimal. So again, this is method 1. One way to do it is root 6.76 is supposed to be 10. Is supposed to be this is supposed to be 26 with 1 decimal. That's 2.6 exactly. Okay, that's one way to do it. Another way to do it is like this. Well, we know that we recognize what are the rational numbers, what are irrational. all the terminating decimals are rational. 2 decimal place means it's out of 100. That's all. So another method is root 6.76. Of course, you also recognize this is a square number. Oh, also, I said in class, if you didn't recognize this is a square number, you can take out one by one. You can take out the square factor one by one. Do you remember I said that in class? You don't have to take out the biggest, 26. Okay, so I will write at the method 3 after. I finish this method 2 first. As I mentioned, is that you 2 decimal place you recognize is out of 100. So that is a root top and root bottom. Root the top is 26. Root the bottom is 10. That's it. And that's exactly the same as this one, 2.6. Okay, or you can write in fractionalist form, doesn't matter. Okay, now the last thing is, just in case someone didn't recognize, okay, maybe I'll write here. What if we don't recognize that it is a square number? What if we don't is that how to spell it? Recognize the big square numbers. Okay, move a little bit here. Yeah, okay, we can take out one by one. So 676. You try. It's already you already recognize it's divisible by 4. 1 is not meaningful. It's divisible by 4. Okay, so that is equals to 4 times 127. Then it is 7. That's 28. No, okay, sorry guys, I have to do it this way. Suddenly my brain is not very clear. 427. Yeah, that's what I meant. And then 4. What is this? 46. Yeah, that's what I want. Okay, 36.9. Okay, 169. Or you can do it like this. You put out a 4 first. Yeah, that's how I wrote in class. Sorry, guys. You take out one by one. Yeah, that's how I wrote it in class before. And then now you recognize this is a 2 times a 13. That's 26. So that you can radical have the lowest term idea. So if you didn't recognize this is a perfect square right away, at least you can take out all the square factors. Okay, so I'll pause here. You guys can write this down or take a screenshot. Okay, so anyway, the answer is 2.6, just in case you don't see it, just in case the too many writing here look messy to you, the answer is this. Okay, before I go to the next question, I know some people are writing, so you keep writing, but I'm asking, like, if other people say that you don't need this question, do you have other thing you want to ask for 1.8.1, other parts, like part A, part C, or part E? Okay, anyone not done this page, type me a letter N, please. You can copy this part now, or you can take a screenshot. You can write it down even. I mean, seems like we didn't have that many questions to take up. Okay, 1.8.6, yeah, I know. Here, sorry, I'll go back to it. Yeah, so this one done, and then 1.8.6. Next is this one, 1.8.4D. Okay, anyone not done this one? Type me a letter N, please. Okay, so next is 1.8.4. D. Yeah, 1.8.6 and 1.8.7, I got those already. Okay, so it's just simplify. So here we have cubic roots of 256, 27 plus cubic roots of 32, minus cubic root of 1281, 12 over 81. Okay, so some numbers you recognize, they are squares, they are not really cubes. Okay, but we can just remember we here adding, subtracting, then we will say to ourselves collect like terms. So I'll remind you that first. For adding, subtracting, or for add, where is the add sign? Add. Okay, for add or subtract, okay, we say to ourselves collect like terms, collect like radicals, like collect like terms. For x, y, z, those kind of thing you call it collect like terms, but for radicals we call it collect like radicals. Recall? Okay, so they obviously don't look like radicals, then we will simplify it first. Now for square roots, we want to take out the square factor. Okay, I'll write another note here. This is a cubic root, the problem is. Okay? For square root, when we write to the lowest form, we want to take out the square factors. Now, this is cubic roots, we want to take out some cubes. Okay, so let's maybe we recognize some cubic numbers. Square numbers are something I wrote above already. So here, let's write down some cubic numbers, just in case someone didn't recognize, or I don't recognize all of them either, so I will just write a few down. Okay, the cubic numbers, of course, are 1 cube, 2 cube, 3 cube, 4 cube. Those are called cubic numbers. Okay, square numbers, as we have seen above here, 1 square, 2 square, 3 square, 4 square, 5 square. Right, so here is 1 cube, 2 cube, 3 cube. Okay, so that's 1, 8, 27. 4 cube is 16 times 4, which is 64. 5 cube is 25 times 5, which is 125. 6 cube is 36 times 6, which is 216. 7 cube is 343. 8 cube, now how about this? Actually, 8 cube, I cannot memorize it in my head either. Oops, I meant 8 cube, sorry. But on the other hand, I recognize the powers of 2's. So again, I meant 8 cube, that's the 2 cube, and then cube, which is 2 to the 9. Then I know 2 to the 9 is 512. Okay, I think that's quite enough. The rest, I don't care. I mean, I do care, but they are bigger and like the questions here don't have those big numbers anyway. Okay, so let's take out some cubes here. In 256, we can take out the 256 is 2 to the 8, right? Okay, so we can take out how many? I mean, so we can see how many we can take out. So I write that this is a 2 to the 8 first because I recognize this. Then this is a 3 cube. Yeah, looking like this, you can try divide by 8, divide by 27. You can try that also. But actually, since I recognize this is just a power of 2, I'll write like this. Then we can easily take out some powers. This is 2 to the 5 cube minus the top here is 2 square and then a 3. The bottom 81 is a 3 to the 4 cube. Okay, great. I have something like suddenly I have a 3 here. I thought it was weird, but actually 3 and 3 to the 4 cancel out. Then you have some cubes there. So here, as I said, you want to take out some cube, and you see 2 to the cube is 2 to the cube will be a cube. 2 to the 6 will be cube. 2 to the 6 is a 2 cube, 2 square cube. So all the multiples of 3 are cubes. When is the pre-assessment? Okay, everything is done. Okay, maybe as I should publish it, I will do it right after this class then. So here we take out 2 to the 6 that you can take the cubic root, and the leftover is 2 to the 2. Bottom here, 2 cube, you can just, 3 cube, you can just take the cube root. Here, same thing, you can, if you make up I mean, if you have enough 2 to the 6, then you have a group done by 3s and 3s. But here we only have 1 3, and then the leftover is 2 2s. So you cannot group 3 out and then another 3 cannot do it. We can only group out one group of 3 of 2s. So we'll take out 3 of it, and the leftover is cubic root of the other 2 that doesn't make another group. And here, so again, it looks a bit annoying for me, like suddenly a 3, what to do with it is not the like term, but actually 3 and 3 to the 4 cancel. So actually I'll use this gray maybe, and this cancel, and so this becomes 3 to the 3. So I have the top is cubic root of the 2 square, bottom is just cubic root of the 3 cube. Actually, another way to do this is you can write this as a fraction exponent, that you can do it. I just, this time I didn't. Again, you can write as cubic, maybe I'll show you here. So next you see, for instance, cubic root, cubic root of 3 cube, if you write in exponent, is 3, 3, 1 over 3, which is 3 to the 1. Yeah, so no wonder cubic root and cube cancel out, just like square and square root will cancel, and just like adding, subtracting cancel also. Yeah, so here you see cubic and cubic root will cancel. Be careful, this is a 2 square when the cubic cancel out. So I'll write another piece here. Maybe start with the top. Okay, so I'll start with the top here. Again, 2 to the cubic root of 2, 6. I meant this. Okay, that is 2 to the 6 and then cubic root. So you see the leftover is 2 square. So you see if you have 6 and 3, they cancel, is 2 to the 2. And here you cannot take out any cubic factor anymore, than this is lowest term. This number is a 2 square, and then the cubic root of 4, and then bottom cancel is just a 3. Here, same, now you can see it right here is the same argument exactly, they cancel. Cube, take the power cube, the exponent cube, and the cubic root, they cancel. So that's a 2. And here cubic root of 4 again is lowest term. Yeah, so they are like radicals right here. Here the top is this cubic root of 4, and the bottom is this cube and cubic root cancel. Maybe I'll use this gray again, cubic root cancel. So that is just a 3. Okay, so we have like term here. You have a 4 over 3 plus the 2 minus the 1 over 3, that many of the cubic root of 4 when you collect like terms. Does it make sense? So here common denominator is 3, and that's this collect to be just 1. Okay, so that's a 3 cube 4. You see here they happen to just collect, don't even have to make common denominator, right? Make just a 1. So 1 plus 2. Okay. Okay, so write this down or take a screenshot or whatever. Write it down quickly. And next is 1.8.6. So I'm going there. You guys can write this down. Okay, actually we have only 6 minutes left. So maybe you guys just take a screenshot here, perfectly 1 page. Okay, 1, 2, 3, cut up. Okay, next is 1.8.6. If not, then I can go back up after. So you can tell me to go back up. Okay, 1.8.6 is find the integer AB such that we want to simplify this 600 minus 150 plus 3 root 54 over 6 root 32 minus 2 root 50 and minus 288 is supposed to be some A root B. Okay, so where root B cannot be simplified. So we want to find A, B are what? Okay, we just simplify this until the end, see what A, B we have. So here at least you recognize 100 right here. So you know where we want to simplify them, adding, subtracting, of course we want to collect like terms, as we said. So to collect like terms, we have to write them to lowest form first. Otherwise, we don't see that they are like terms at all. Just like previous question here, looking like this, we don't see that they are like terms at all. But after we write them each to the lowest form, then we can see they are like terms, like radicals. Okay, so you all should recognize the 100 you can take out right away. Here 150, let's see, divide by 25. I only see 25, I don't see the next number yet, but if that's not the biggest square factor, I can take out one by one. So at least I see 25 first. So that's a 6. Okay, give us a hint here, probably because 6 is lowest form. Probably the like term here is root 6. And let's see here. 54 you recognize, you can take out a 9. Okay, yeah, exactly. Root 6 is lowest term, that's the like term here on top. Okay, bottom here, 32 you can take out a 16. 50 you can take out a 25. Okay, yeah, it give me a hint that root 2 should be the like term here. 288 is 144, you can take out a. Okay, yeah, so it looks very simplifiable. That's 10 root 6 minus 5 root 6. That's a 3 root 6. So that's a 9 root 6. Okay, so let me be lazy here. That's a 6 4 root 2. That's a 2 5 root 2. And that's a 12 root 2. Okay, so yeah, this one don't have to write. Okay, the black. Okay, so this is a 6 4, which is 24. This is a 2 times 5, which is 10. This is a 12. Okay, so we simplify the top here. 10 is 14 of it. Bottom here, 24 minus 10 minus 12 of it is 2 of it. And now, of course, we want to simplify this is that radical by radical, number by number. So number by number, they cancel. That's a 7. Radical is also that recall root A B equals to root A root B. So root 6 over root 2 is just a root 3. So this is just 7 root 3. Does it make sense to you? This is the lowest term. Okay, so A is equals to 7, B equals to 3. Okay, take a screenshot or write down quickly. Then next I'll do 1.8.7. Is it clear to you? Is the writing too messy? Next question is similar. I can try to write meter. Or is this okay to you all? Okay, anyone not done this one, type me a letter N, please. Okay, so 1.8.7. Something similar as before. Negative root 20 plus 2 root 245 over root 270 minus root 120 is supposed to be some A root B, and we want to find A, B are what? Integer A, B. Yeah, previous question was also that we want integer A, B. So that's why we need to not doing any square roots. We need them to be integer. Okay. Yeah, here. Okay, so same thing, adding, subtracting. We want to collect like terms, then we have to write them to lowest term first. So here I recognize you can take out a 4. Yeah, 5 is lowest term already, so I bet here the leftover is a 5 also. So let's just directly divide by 5 and to check is the leftover number a square number. 5, 4, 9. Yeah, exactly. So yeah, it tells you it is a 2, 4, 9, 5. Again, I get the hint from that this is a 5, then here the like term should also be 5. That's why I just divide by 5. Instead of trying 1 square, 2 square, trying to divide by 4, try to divide by 9, trying to divide by 16, 25, you know, instead of trying like that, I just have this hint. Okay, so here 27, 9 I can take out at least. The leftover is 30. 30 is 5, 6, so there is nothing else to take. Okay, so I'll take out root 9. Here, take out root 4, I expect 30 should be the leftover. Okay, so indeed, you see 30 is lowest term. 30 has no square factor. So this is the -2 root 5. 2 set. Okay, can I be lazy again? Just this is 7 in my head. So I'll directly do this is 2 times 7. Be careful. Okay, that's a 14 root 5. Bottom here is 3 root 30. Okay, not a root 3. Root 9 is a just 3. Root 4 is a just 2, not root 2. Be careful. Sometimes just careless. Okay, so that's a 12 root 5 over root 30. That's they cancel here. It's a 12 over root 6. Up to here seems good. But the problem is that's not quite look like this. Okay, so we know that to rationalize the bottom, you multiply by root 6, you can make it to become a nice integer. You all should know that root A equals to root A squared. That's A. Root A is just A. Root A over root A is 1. Actually, I forgot to write this in the first class. In my notes, I have it, just I didn't see it when I did the class yesterday. But so I forgot to remind you. But also, actually, of course, maybe some of you don't need my reminder anyway. Root A is the 8. So to make a nice number, multiply the root 6 also. Then you will get a nice 6 at the bottom. Okay, so now we see this cancel. That's a 2 root 6. Root 6 is lowest, 6 is lowest term. So yeah, we have A is 2, B is 6. Okay, that's it. Anything else you asked and I didn't pick up? Tell me now.
When's the video gonna be released for this?
Right after. Well, actually, maybe 2 hours later. Maybe 2 hours later, maybe.
When is the pre-assessment gonna get graded again?
Okay, I'm going to, it's all graded because, but I haven't, I thought I didn't have to publish it, but maybe I have to. So yeah, I will publish it right after this class.
Okay.
Is there like an answer key?
Answer key? The textbook have an answer key. So when your
Okay.
book arrives, you will get them.
Is there an online one?
Online don't have.
Okay.
So, well, if you are using the online version, then there is an answer key on the online version. But if you are asking, can we post the answer, then we don't have it. So yeah, you should come to class and ask the questions. You should do them and ask. You can at least ask me to check, like if you want to just know the answer for certain question, I can tell you quickly next time, but now it's done. If you really have to ask, I can do it now. I can stay for 10 more minutes. The textbook is Introduction to Algebra. As you can see on Piazza. Do you remember? Should I show you now on Piazza? Who wants to see it? Yeah, people who raised hand, say it. Okay, one sec. One person. Oliver. Okay, ask now what?
Is there like a Piazza with like a grade scope code?
We don't have grade scope because you don't have to submit anything for this term.
Okay.
So we have no grade scope for this term. Okay, and then Ryan, what?
Is the pre-assessment where is the pre-assessment going to like put on?
Okay, did you hear someone ask it already? I have to publish it. So yeah, right after this class, I will just
Publish it on Piazza. Publish it on Piazza.
No, it's not Piazza. You will get it in the email. You remember you enter the email on the Google form. That's where you the results will send to.
So when is the email going to be sent?
So I said that I will I will publish it right after this class. So I just have to click a publish button, then the email will send out. So just right after we are done, I will publish it already.
Okay, thanks.
So give like 20 more minutes for sure you can get that email.
Okay.
So yeah, anything else to ask? Type me a bye. Okay, if you have everything is good. And if you want me to scroll up, down, left, right, tell me now. Okay. Anything else you want to ask? Or someone said you just want to quickly check the question's answer. The final answer, I can check it with you now also. Like just certain questions you want to check, I can do that. Homework answers are not posted, but this video will be posted on Piazza. So no homework answer, like PDF version, we don't have that. That's why you have to come to homework class. Okay, so if everything is clear, you can go now. If you have something you want to ask, you want me to scroll left, right, up, down, tell me. Okay. I will publish it now. Let me go to the Google form again. Google pre-assessment. Okay, Diana, do you have questions? KT? If not, I will stop recording.
Oh, I'm sorry, I don't have any questions. Bye.
Sorry?
I don't have any questions. Thanks.
Okay,
Class.
you
Bye.
can go. Okay, bye-bye. And Katie, Katie. Okay, Katie, are you still here?
Yes.
Do you have questions?
No, I was just reading the equations.
Okay, so I will stop recording now.